Hey guys, Mrs. Traver here. We're going to do our notes on sections 10.2, 10.3. Those are on radicals, and this is going to be a three-part video. I'm combining the two sections, but I'm doing it in three parts, so it's kind of sketchy how it worked out, but that's how it'll play. So let's check out the beginning. Before we do anything else, I kind of want to show you like our game plan. We're going to think about first the first part mainly in simplifying and add and subtract. And then in the second part, we'll do multiplying, and in the third part, we'll do dividing them. So that's kind of the game plan. This will be the biggest of the three sections, mainly just because the simplifying will take a minute. So let's start with simplifying then. So let's simplify by taking out a perfect square. So before we continue, we should make note of what all the perfect squares are. Perfect squares are those that when square rooted work out perfectly. So what we really want to do is think about like our multiplication table and everything that's on the diagonal. So like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144. And I'll stop our list there. But what I want you to notice is that the square root of each of these is 2, 3, 4, 5, 6, and so on. So if you have this list down, then this method will work for you. I'll show you another method where if you don't have this list down, if you don't have your multiplication facts down, then you can do a factor tree instead. So that one takes a little bit longer, but it'll work just the same. If you know your multiplication facts pretty well, then this simplifying by taking out a perfect square will work quickest for you. So if I gave us an example like the square root of 16, what we're looking for is, does anything that's perfect go into 16? And 16 is actually on the list. The square root of 16 is 4, because 4 times itself is 16. So when we do these type of problems, usually it's not going to work out just like that. Maybe we have the square root of 160. So what I want to do is look at what's inside the radical. This square root sign is called the radical. And see if there's anything that's a perfect square that goes into it. So we want the biggest one we can find. So starting on the right, working our way to the left. Which of these goes into 160? The first one is 16. So this is 16 times 10. And we know the square root of 16 is 4. So this is actually a 4. So it's going to come out of the radical and be a 4 on the outside. So this is really 4 root 10. And I know I'm all done here because the 10 that's on the inside can't get simplified anymore. There's nothing on this list that goes into 10. All right, let's do another. What if we had the square root of 72? So let's see, something on this list that goes into 72. And if you don't know your facts very well, again, you could just check them. On here, you could be doing 72 divided by, and then again, start on the right, work your way to the left. I'm not going to check anything bigger than 72, and 64 is too big, and so is 49. So maybe we'll start with 36, and boom, there we go. We got it right off the bat. Maybe you don't know your perfect squares very well, and you could be doing 72 divided by 7 squared, 72 divided by 8 squared, 72 divided by, I should go backwards, 6 squared. And then we would have got that. So 72 is 36 times 2, or 6 squared times 2. So 72 is 36 times 2. And the square root of 36 is 6. So that'll pull out and be a 6. And I'll be left with 6 root 2. So let me try this problem one more time. I'm going to do number 3 again. But this time I'll do the factor tree. So let's do the same idea. But I'm going to take this 72 and do a factor tree. So whatever the first fact that comes into your brain for 72, you can use. Like the one that comes into my head, is 9 times 8. And then 9 can get broken down into a 3 and a 3. And 3's can't get broken down any further, they're prime. 8 can get broken down into a 4 and a 2. And then the 4 can get broken down into a 2 and a 2. So if you do this factor tree and you get all the way down to just prime numbers on the outside, then you can take them in pairs. So there's a 3 pair and a 2 pair. So that's a 3 and a 2 on the outside. And then left on the inside is a 2. So we would have been left with 6 root 2. And that's the same thing we got. So if you'd prefer to do this tree, the game plan is whatever you can pair up, take one of them and put it on the outside. And whatever's left over stays on the inside. Either of these methods is fine. All right, let's do another one. Let me throw some variables into the mix. So what if we did the square root of 80x squared? So I'm going to do this both ways for the rest of these examples so you can kind of choose, and then from there forward you can pick which one. So what goes into 80? That's a perfect square. Let's do that method first. So checking out our list here, none of these will go into 80. 25 doesn't. Does 16 go into 80? Let's check. It does. 16 times 5 goes into 80. And then this x squared, let's just leave it as x squared for now. So let's see, what's on the inside? This 16 is going to come out as a 4. And then the x squared, let's think about that for a moment. If we have the square root of x squared, which is what's happening here, we're really asking ourselves what times itself is x squared, which that's just x. So x times itself is x squared. So the square root of x squared is x. So I can pull out an x. So on the outside, I have 4x. And on the inside, I had a 5. So if we were going to do it the factor method instead, I would take that number 80 and break it down maybe into an 8 and a 10. And this would have got broken down into a 4 and a 2, and then a 2 and a 2. And then this one a 5 and a 2. So let's see, I'd have a pair of 2's and another pair of 2's and a 5. So that would have given me 2 times 2 root 5. So 4 root 5. You can tell my 4 root 5 is hiding in there. So then separately you mess with that x squared. So that works as well. Let's do another one and then we'll move on. So how about the square root of 54 and the 5th? So let's check our list. What goes into 54? That's a perfect square. Let's start with, I'm not going to start until I get to like 36. That's too big, I know though. Does 25 go into it? No. Does 16 go into it? No. Does 9 go into it? Yes. 9 times 6. Hopefully you knew that one, but there it is. 9 times 6. And then let's break down this ends to the 5th a little bit more. I'm trying to, with my numbers, make them be perfect squares when I break them down, and I want to do the same thing with my variables as well. So I want to try to break down this n to the 5th into squares. So I have 5 n's to work with. Maybe if I just write them a different way. So like if I wrote it as n squared, n, notice here I have n, 5 n's. Here I have n. Still 5 n's, just written a different way. And the way I wrote it's nice because those perfect squares will come out. So all of our perfect squares are the 9. That'll come out and become a 3. The n squared, what times itself is n squared, that's going to become an n when it pulls out. And this n squared as well will become an n when it pulls out. So I've got 3 times n on the outside, and on the inside I'm left with 6n. Final answer, let's simplify a little bit. N times n is n squared. So 3n squared root 6n. All right, and last time I'll do this 54 chart. Maybe we've noticed the 9 times 6 breakdown. This 9 becomes a 3 and a 3, and this 6 a 3 and a 2. So we would have pulled out a 3. On the inside, we would have been left with a 3 and a 2. So 3 root 6, 3 root 6, and then the variables you can do separate. All right, I'm going to pause this video here, and we will pick back up in a moment with the simplifying.